my laptop screen anyway. Okay. Let's see.
Okay, so I think this one, don't we just put the two z-scores in and then just highlight the middle and then do the two z-scores?
I think so. So I'll just put one on one side is what you're saying, and the other.
Oh wait, like, under the standard normal curve. Oh, it would be all of it then, right? Because
if it's normal.
Yeah. Well, and the applet only does normal probability anyway. Oh yeah, so see.
Yeah, so you just throw it in the applet.
Yeah. But I think it all needs to be highlighted, right? Because it's asking for the combined area under the whole curve.
Mm-hmm. Okay. I think so.
All right.
Hi, Mom.
What's this?
Or is it just the middle?
No, I think it's to the left and to the right. Like, so you skip the middle, right?
No.
Right.
Well, it's saying the combined area under the standard normal curve. Because remember, everything under the normal curve has to equal 1. I don't know. That's how I would interpret that. So
the answer would be 1.
Well, no, it would. Well, I don't know. Let me see.
So if you guys put it in and it's all highlighted, your area is 1, right?
Yeah, it would be 1 if it was all highlighted.
Uh-huh.
But it's saying, so I don't know, maybe I'm wrong, but it says,
what do we highlight?
To find the combined area under the standard normal curve that is to the right of z, so to the right of your z-score, and to the left of your z-score.
So you're saying
it's add those two. Is it just like was there a question on the homework that was like this?
No.
No, not that I remember.
I feel like I saw in one of the videos him highlighting the two sides, but do we go with 1?
Yeah, that's weird. I don't know.
Well, we get 2 attempts, so.
That's right.
Good point. Good point.
Well, what happens if you don't highlight anything and you put that z-score in? What does it do? Nothing.
Oh, it just is 0. The area is.
Yeah. Yeah. Obviously, something has to be shaded.
Mm-hmm. Yeah, that's confusing. To the right and then to the left of each z-score.
I think it's just the two ends, but that's just me.
Okay.
Yeah, I think that you're right.
You're combining those
0.75. 0.175.
Well, let's just do that then.
Yeah, 0.175.
Yeah, that's what I was going to do. So, yeah.
Mm-hmm.
Okay, which of the following will have a smaller standard deviation?
What does X stand for again?
The given or the value?
Yeah.
I don't know about the X with the little squiggly line on top of it.
Okay, that's what I thought. Yeah, the squiggly line is throwing me off.
I have no idea. Do you guys know the exam, does it cover lesson 1 through 7, or is it covering lesson 1 through 9?
I think just 1 through 7.
Yeah. Okay.
I don't know.
My first is the first one without the line on top. But I don't know why.
Okay. Well,
Does it
Yeah.
say anything about being skewed? Let's see. Yeah. Mm. I don't know. What do you guys think?
I don't know. This one's a toss up.
I would just be guessing.
Standard.
I think it's either 1 or 3. I don't know. I'm gonna go with what you said, Elise. I'm just gonna do 1.
I think so too, because it's individual observations, the distribution of the individual.
Mm-hmm.
Okay.
Wait, what are you guys putting?
The first one.
Mhm.
Oh,
I know I can't find. I'm trying to find notes on it, and I can't find it.
Mm-hmm.
So when we first started doing standard deviation stuff, I don't remember the standard deviations being as big as they have been this past week.
Mm-hmm.
And this past week, with the distribution of sample means, it always has the line on top.
Yeah.
So all week it's had the line on top, and I think that they're bigger. I think that's all I'm going off of.
Okay. Well,
Better than nothing.
We'll see.
you said?
Okay.
You said you're doing the first one?
Yep.
hmm Okay.
But feel free to do whichever one you feel like.
Well, maybe as we keep
I know,
doing
you
them,
can
maybe.
take it twice, so I'm like,
Hmm.
I don't know, I guess if it's a guess. Multiple guess.
Oh, number 5. Okay, is this one the central limit theorem or the law of large numbers? I know it's one of them. I saw it on the video.
Something decreases. So the law of large numbers, the sample mean increases. The sample mean. Sample n increases.
I think that's what the line over x is the sample mean, right?
Hmm.
Yes.
Yes, it is. I see that
Yeah.
in my notes now.
Yeah.
Yes,
I just
the
saw it
sample
too.
mean.
Okay. So what did you say? If the sample mean increases, so it wouldn't be. Oh wait.
It's a sample n.
The law of large numbers, as the sample size n increases, the sample mean draws closer to the population mean.
Yeah, I don't think it's the law of large
Or-
numbers.
So the central limit theorem, as the sample size n increases and becomes large, the distribution of sample means becomes approximately normal.
Oh, well, it might not be either. Decreases as the sample size increases.
Increase.
What are you guys gonna say on this one?
I don't know. Remember on the last quiz, we got them mixed up. This is one of the things that I hope we go over tomorrow to kind of understand the two better.
Mm-hmm.
So I have on my notes, the law of large numbers is what happens to the spread. The central limit theorem is what happens to the shape of the distribution of mean. So maybe it's the law of large numbers. That's what I'm going to guess.
Because it's
Yeah.
spread.
Because what?
Because it's the spread we're talking about.
Yeah.
Spread increases.
Yeah.
Too, it helps to imagine like what the heck
Yes,
we're talking about.
Mm.
Spread as the sample size increases. Because the sample size is how many people. So if you're thinking of like graph, sample size is going to be on the bottom, right? So as you have more, the spread would decrease, right? Because it becomes a normal distribution, right?
Yeah, it's
Becomes,
I think so.
what is that called?
it gives more accuracy. Yeah. Oh. So what are you guys thinking?
I don't know.
Could it be normal distribution too? Because as the sample size increases, it becomes more normal?
Okay.
I don't know.
I don't know.
When the distribution,
I don't know. I'm trying to find something about it, but
Yeah, me too.
when is distribution of sample means X normal? When the parent population is normal and or sample size is large. Hmm.
I'm going to involve large numbers and move on. I don't know how we're going to.
It's fine. I know. I'm sorry, Elise. I know you have to go in like half an hour.
oh, it's fine. I'm trying to find it too, so
Yeah.
we can move on though.
I have no idea. If we all guess something different and we get the answers, we'll know.
All right, I just guessed and moving on.
I'm guessing. Okay.
Okay, number 6.
Scores on the quantity.
So we're looking for the z-score.
Mm-hmm. But I think it's the new formula that we learned, where it's you have to do the square root. You know what I'm talking about? The ones that we did in yesterday's homework. It's a little bit different. The z-score is a little bit different than the first one we learned. Okay, so.
So it's x minus mu.
I need to have this formula written down because I get.
With
So
the
isn't
standard
it-
deviation
Isn't it the values
divided
minus
by
mean divided by standard deviation?
square root of
Oh no, you guys are right.
the square root of the sample size?
It's okay. So it's yeah, square root of sample size.
So
So 160 would be the
can we,
variable.
do you know for the test, can we use like scratch paper? I'm sure we can. Is that a stupid question?
I'm sure we can.
I mean, I wouldn't see why not, but
So here, I wrote it out. So it's variable minus the population mean divided
variable?
by,
Standard deviation, right?
yeah, the variable is the 160 in this example.
What's the variable? What symbol is that?
Isn't it the 160? Diane's score.
It's whatever you're trying to find. Variable is the thing that changes.
Oh, it's X with the squiggly.
And sample mean, or sample size. Hello.
So sample mean minus,
Well, the value minus the mean divided by the standard deviation.
so the value is
The 160.
the 160
Minus the mean.
minus
The mean, which is the 150.8.
And then the standard deviation is 8.8 divided by the square root.
square root of n, which n is sample size.
Oh, maybe it is the first one because we don't have a sample size.
Yeah, I think that it's just divided by the standard deviation.
Yeah. Okay.
It
Annie,
should
you're
be 1.045.
That's what I got.
Would you say 1.045?
0.045.
Yeah. So I guess that's how we would tell the difference of when to use those two equations, is if there's a sample size given or not.
That
Okay,
makes sense.
What are we supposed to round to? 3 decimals?
Yeah.
Okay.
Which formula did you use then?
The normal z-score.
Why did I get something different? Oh, I think
It's just the variable minus the mean divided by standard deviation.
okay, there it goes. I plugged it in wrong. 1.045. Sorry guys, I'm slow. Okay. What is the probability that a randomly selected split above 160?
160. So don't we just take that z-score and put it in the applet? And
I think so.
You should just the left, right?
Above 160. So above, greater than. So wouldn't it be on the right? Or no?
I thought greater than was on the left.
I thought greater than was on the right.
I thought it was right because the left is negative, isn't it?
Yeah.
Yeah, the left. I know what you're saying though, Elise. That's what confused me last night when we were doing the percentiles. We do shade on the right, but these problems, for whatever reason, we shade on the, or we were shading on the left.
Either
might
one,
be
it's
just
the same. It's the same number.
So what did you
Is it?
get when you plugged it in?
There you go.
0.1480.
Me too.
That's what I thought.
1.480.
Oops, I'm plugging it in the wrong spot. Oops, I better make sure. Okay.
So 0. Wait, sorry, what'd you say?
0.148.
48, yeah, okay.
Oh, I added an extra number in there. I added a 0 at the end. Not thinking. Okay. So now we have to find the mean of all of these numbers, right?
So we just add them up and divide them by 5, right?
Yeah.
So I got 160. Was that right? Let me see.
Wait, what did you get?
I got 160, but I may have done it wrong. I'm going to add them real fast again.
I got 160.
160, yeah.
Okay, good.
Yeah, and I must like plug things in wrong on my calculator.
Okay, so then the mean is 160. So then how do we like find the z-core for that? Because it says corresponding to that sample mean, which is the 160.
Well, if we know what the mean is median. I get confused. What is a median? What is that one?
Median is the middle.
Just the middle number?
Mhm.
Okay. Hmm.
Oh, this is where, yeah, I'm confused here.
Well, if we put them in,
Because this is giving you a different mean than the 150.8. So you still,
You don't have the standard deviation.
So do we have to find the standard deviation and then plug it all in?
but the standard deviation up in where it says use the following information to answer the next 4 questions, the standard deviation is 8.8.
Mm.
what? Oh, the next 4 questions. So 1, 2, oh yeah. Oh, you're so smart.
Oh, that changes things.
Not very often.
That's not
now
true.
We're dividing by 8.8.
So what value do we plug in though for the x?
So I'm getting 1.045.
What
1.045.
What
Again,
value did you put in of the 5?
for
Yeah, what do you plug into the equation for the x?
or is this where we have to flip it and we're finding x?
Wait, what?
So wait, x is the sample size, right? Or no?
X is the given value, the given or the value.
So would it be 5 because it's 5 students?
Right, that's what I was thinking.
Wait, oh, is this a tricky question?
Oh, this is the one where you do the 5 students and the square root, right? Because the 5 students
the
would be
sample
the
size.
population size, the sample size.
But I'm so confused. Why did we have to find the mean? If they gave it to us, they said that
That's what I was thinking too.
because it says for the next 4 questions, and it already gave us the mean and the deviation. So a random sample, their scores are. What is the z-score corresponding to the sample mean of these students' scores?
So I guess it didn't tell us to find the mean though. It just said find the z-score. So use the mean that already gave us.
Yeah, right.
This is true.
Well,
So how do
and so the sample size is just the 5.
Mhm.
Right.
Those, okay.
So what equation do we use for this? That's what I'm.
Yeah.
It's the same z-score, but then you're going to do divide by the sample mean, or square root, sorry.
The square root of the
So it's going to be the variable
minus.
minus the mean divided by the standard deviation divided by the square root, the sample square root.
So then what's the value? The value, are we still, is that what's,
Oh.
that's what I'm,
Yeah, that doesn't make sense then.
What's the mean of random variable?
so I'm missing the value in my equation.
Mm-hmm.
Right. This does not make any sense.
Let's just invite the TA to every meeting the rest of the semester.
Please and thank you. I don't know.
I just don't understand what the value is supposed to be.
Right.
It's not all of the student scores, right?
Hmm.
Because if it was, we'd have to like add them up. We'd get the 100 or whatever. I don't know if that's right.
Well, we don't have anything else to go off of,
Is
so
this the one where you solve for x?
Yeah, that's what I was wondering.
Because x is what we're missing.
because that's what you said like 5 minutes ago. Yes. So solving for x is the mean.
No, wasn't there a homework problem that had this?
I don't remember this. Not
Condos.
Yeah, I don't remember one like this.
Mm-hmm.
Is it a wacky number, Danny? Did you try it by adding those up and letting that be your value?
Oh, so like the 800 minus 160 divided by standard deviation divided by square root of 5?
Yeah, I don't know. Well,
Yep.
because so if you do, and then Joe, you said solve for x, which is the mean plus.
I don't think that's it because we're trying to find the z-score, and you need the z-score to solve for x.
Solve. Okay, so it's not. Yeah.
Mhm.
Okay.
That's true. So z is equal to.
Yeah, other than adding those up, yeah, I don't know how you get the value. I don't know. What are you guys working on?
I'm just trying to find something that talks about this so I can figure out what we're supposed to do here.
Anything on last night's homework or in my notes, like from videos?
Yeah.
This kind of example. So if we did that, I don't know, that seems like really not correct. Because the z-score would be 164, which is, that wouldn't even be anywhere near. Yeah, no, I don't think that's right.
You guys want to move on?
Do we need to find the standard deviation so that we can find the z-score?
They give us.
Doesn't it give it to us?
Does it?
Yeah, it's 8.8.
Oh.
We know what it is. We just don't know what the value is. At any rate, yeah, we can move on. You only got like 10 minutes.
Mm-hmm.
So maybe we can come back to this.
Okay.
Well, maybe not.
All right, so number 9.
We need to know what the answer was to the previous score, previous problem.
My guess.
Gosh.
Oh, shoot.
I bet once we like get it, we'll be like, oh yeah, duh.
So we're moving on to question 10 and skipping 9. Is that what you said?
Well, because you need to know 8 to do 9.
Yeah.
And we don't know 8.
And so what is the shape of the sampling distribution?
So it's telling us it's left skewed, but the random sample is high. So it's either left skewed or approximately normal.
Mm-hmm.
I'm going to say approximately normal.
Mm-hmm. Just because the sample size is high?
Yeah.
Wait, there was something like this in the homework.
Yeah, there was.
I saw on the video.
I think it said we couldn't determine.
But I don't know how they tell us, you know, but I don't know how you know that for yourself. Like, how do you know what I mean? Like, what's the rule, or how are you supposed to know?
It's not a big enough sample?
So you're saying that we can't determine from the information given?
It gives us the standard deviation and the distribution. And the sample, isn't that enough? I don't know.
Yeah, it might be. I have no idea.
Yeah, I know nothing, you guys.
So, like, for example, last night, see, I even made a note. Why? How do you know that? The question was a sample size of 4 is taken from the right skewed whatever data. You want to and you want to know the probability that the observed of the observed. Can you compute this probability using the normal probability applet with the information you have? And he said no, because the distribution is not normal. And the applet only works for normal distribution. But I don't know why you just know that.
I don't know either.
I don't know.
But basically, what that's saying is that we can't determine it, though, right?
Yeah, I'm gonna go with what you said, that it's big enough, only because on another problem, the sample size was 4, and it was taken from a right skewed. And what is this? And it asked what's the shape of the distribution, and it was still right skewed because there wasn't enough samples. It wasn't big enough for the central limit theorem.
So you say approximately normal?
Yeah.
Yeah, it sounds good.
I think so.
I'm gonna do that. I'm gonna do that one. I don't know if it's right. Could be totally off.
That's what I was thinking. Though.
Okay, do it again.
But I do have a question about that. Like, I want to know how they know.
Mm-hmm.
So,
Okay, so mean of the distribution of sample means is the U times this. No, I don't get it. I'm not yawning.
no. So I'm visiting my family and I left my computer cord at my house and my computer is dying.
Uh-oh.
Uh-oh.
That's cool.
You gotta go.
Oh, no. And you started the chat, right?
Yes, I'm so sorry, you guys. I just realized. I should be okay for at least like a half hour. Should be. So I'm sure we can get it done. I just wanted to let you know. I'm sorry, you guys.
Okay.
Okay. We're on 11, right?
Yes,
We're on 12. Are we on 11?
we are on 11.
Sorry.
Oh, yeah, we are. Okay. What is the mean of the distributions?
Bah. Okay.
Was there one like this on the homework?
Yeah.
I'm looking.
Well, like 5 through 9. Seems very similar. What does it tell us? It tells us that it's the distribution is left skewed.
You have to go back.
Oh, Annie's done. You guys get her text?
I did. I wonder if we can just copy this link and send it to her.
I don't know how to do that. Do we
I
want
don't
to
know.
close this? Yeah, it's still on for us, but
Yeah, I know. Is it still live though?
it
Even
is,
if it's not still live. Oh,
it's showing that it's still live.
Yeah, it says it is.
Yeah. Do you want me just to do a new one? That way she can save it and just turn it in.
yeah, that's fine.
Okay.
Do we need to go live on another one too?
Yeah.
On the next one? Okay.
Or you think what, an hour is fine? Oh.
I think so.
Okay.
She can see that we were all present.
Yeah. Yeah, I think so.
Okay.
Okay. All right. So who's starting a new one? Megan, are you starting a new one?
Yeah, well, do we need to start a new one if we're not going to record then?
I thought we are recording still.
Yeah, it is still recording.
Yeah, I don't know.
Unless
Do
she
we
stops.
re-invite Annie? Wait.
Oh yeah, we need to invite Annie.
That's all we need to do, right?
Okay, yeah. I'll start a new one.
Wait, you can't invite her. She has to invite. She has to be the one that invites, right?
I
Yeah.
believe
I don't have a
so.
link to the Hangout either.
Well, hopefully she has it.
She can't just jump back on.
I don't know how that works.
Hmm.
She set it up. I don't even have a thing for the link yet on my end. I can't. I don't see anything.
Oh, is that her again?
Oh,
Yeah.
Oh,
There we go. There
okay,
we
let
go.
me back on. Sorry, you guys, I like freaked out. Okay.
genius.
That's okay.
Okay.
Okay, so are we still on question 11?
Yes.
Yes.
Oh, okay. We didn't figure it out while it's gone?
What is the mean of the distribution of sample mean? Sample mean distribution of all possible.
Okay. What is the mean of the distribution of sample means? Did they not give us the mean, apparently?
Okay, so
Well, it says the mean is
it
3.5,
says that it's
right? And isn't the sample mean the mean?
The mean of the distribution of sample means equals the mean of the parent population.
Right. And so it says use this information for the next 5 questions. So for the rest of these questions, and it's saying that the mean GPA of the students is 3.5. The standard deviation is 0.7. And the random sample is 80.
Is the parent population 81 students?
so what's the standard deviation?
0.7.
And then what was the sample size?
81.
81. So is the sample size the mean of the parent population? Wait, the mean of the parent population.
So
What do we just plug that in?
I just did the standard deviation divided by the square root of the sample size
Mm-hmm.
and got 0.08.
You only did that equation. You didn't do the, what is it?
Because that's how you find the distribution of sample means, and then after that, then you figure out the probabilities. But do we have to figure out the probabilities for this one? I guess so. It says all possible samples. I don't know.
Okay, so I wrote in my notes Notes don't do very much good. Sample size. Okay, so the similar. Oh, I see what you're doing, Elise. Yes, no, you're right. And then we use that to get the z-score.
That's what I was just thinking.
Yes, you are correct.
But you use what for the z-score? Or
You have to do what Elise said. You have to take the
Standard deviation.
standard deviation divided by the square root of the,
Sample size.
yeah, yes. This is because it's not normally distributed, because this is left skewed or right skewed. What did it say? That's why we're doing it this way. It's left skewed.
Oh, you would divide the 0.7 by 9 or whatever the square root of 81 is, right?
Sorry, I'm not there. Okay. Okay, so what did you get for that equation?
0.0777. So
Me too.
So 0.078?
8.
or what does it say to round
is
to?
it just 0.1?
So it'd be 0.8.
Oh,
Yeah, 0.1. 0.1.
Wait, what are we rounding to?
Oh, 0.1 because you're rounding up.
Yeah,
But-
it's just the 1 decimal place.
Okay. That makes sense. So that's the answer for 11, right?
Yeah, because that's the mean.
Right.
Okay.
So, and then number 12. I don't know. Again.
So we're supposed to find the standard deviation.
Of the distribution of the sample means. So did we just said the sample mean is 0.1, right?
Mm-hmm.
And then we have to find the standard deviation.
Of the distribution of the sample means for all possible samples of size 81 grown from the parent population.
So I have, was this in lesson 6 too?
Hmm.
I don't think so.
Yeah.
Maybe. So the standard deviation of the distribution of sample means is the standard deviation divided by the square root of the sample size, where O is the parent population standard deviation and N is the sample size.
Wait, read that again, please.
The standard deviation of the distribution of sample means is the standard deviation divided by the square root of the sample size,
Okay.
where whatever that symbol is the parent population standard deviation, and N is the sample size.
Okay, so we need to understand that second half because we already got that first half. is asking for, what is the standard deviation?
So in this question, would n be 81?
Sample size,
Uh-huh.
I think. Yeah. For all possible samples of size 81. That's so interesting. What are we even talking about?
I know.
We're talking about GPAs. Oh, no. A random sample. Oh, it is. It tells us that. Sorry. Yeah, random sample of N is 81 students were drawn. So is this just that equation?
So, but we have to divide something by 9 because 9 is the square root of that.
Couldn't we just do the full equation now? The
Okay, I have like 7 minutes before I have to go. So my question is, what do we divide by that?
I don't know, guys. I'm so lost. Well, it looks like 13 and 14. We'd love to do on the applet. So
Should we move on?
I don't know. Are you guys coming up with anything?
Let's see. So we need to find the z-score on 13 and 14. So if we found the standard deviation, yeah, then we could do it.
So the formula that we're using is they're not ripe yet. You can't eat it yet.
No, Mom. They have some.
They're not ripe.
They're right. Yeah, they are.
Okay, whatever then. It's fine. Go. You shut the door. So we're just using the z-score formula, but doing the square root of the sample size, right?
For which one?
13.
The z-score formula except doing the square root, is that what you said?
Yeah. Isn't that how we would solve this?
Try it.
Might as well write something down, right? We can always take it again.
So, will be less than 3.3. So it would be 3.3 minus
Don't we need the standard deviation to do the z-score?
yeah, but they gave us the standard deviation. Didn't they? Yeah, is 0.7.
Where does it say that at? Oh,
Right above the question.
gotcha.
And what did you guys get? Oh, I think I did it wrong.
So this one is 3.5. And then the standard deviation is 0.7.
Elise, how much longer do you have?
Just a few more minutes.
Divided by sample size, which is okay, so I got a negative 2.5714. I don't know what we need to answer. But that's what I got for that one. Whether
You
it's
got for 13?
I don't know. For 13 or no, 12.
What did you get for 12?
Wait, sorry, not 12. 13.
Wait, what did you guys get for 13?
We didn't. Oh. Wait a minute.
Wait, did you do 12? Who got 12?
Oh, am I doing 12? Dude, I'm so off right now. What did I just do?
I think you did 13.
Did I? Oh, it would be less than 3.3. That's done on the applet.
So you're negative.
But that answer that I just got, what did I do? That's not right. I don't know.
All right. I gotta go.
Gotta go.
Yeah, so I'm just gonna have to hope that I can finish this later.
Mm.
Okay. Sorry. This is a bit rough.
Yeah,
It's all
sorry.
good. All right, have fun.
Okay.
Mm.
Thanks.
Yeah.
Bye.
Oh, okay. That's what we need to do, guys. Now you take that number and then put it into the applet. Okay. And then the area, whatever the area is, that's the answer.
So what do we put into the applet? I'm confused.
The negative 2, wait, what is it'll be less than 3.3. So less than is negative, so I'm going to shade the left. And then put negative 2.571. And then the answer would be 0.0051, which would be 1, 2. That doesn't make sense though, because it's saying the probability would be percent, unless it's 0.51%, so less than a percent. I don't know. I have nothing else to go off of, so I'm just gonna do that.
And that was for 13.
Yeah, 0.005. Yeah,
That sounds good.
I don't know
Yeah.
if that's right, but
We're probably gonna have to do it over anyways, so. Joe, how you doing?
I'm still trying to figure it out. You guys skipped 12, right?
yeah.
Mm-hmm.
Did you skip 11 too?
No, 11 we got a 0.1.
0.1, okay.
Mm-hmm.
And you're at
So
14.
I'm just going off of last night's homework, just kind of mimicking the problems, and that's what they did. That's what they did there. So less than. Okay, and then this one's the same thing but greater than. So we would just shade the right side and then put in a positive 2.5714, and then that should be the answer for anywhere near this.
And we just shade the left side, you said?
Well, it'd be the right side.
Gotcha. And you plug in the 2.574?
5714.
Oh, 5714, my bad. Okay, what did you get for that?
Not yet.
I think I did it wrong.
Sorry.
No, not at all.
So you have to have the answers to the last few questions to get question 14, right?
No.
No? Okay.
No, you just need the z-score formula. And what you get from that, you take that and put it into the applet.
Okay.
Wait a minute. Greater than. Yeah, okay, and then less than. Yeah, greater than would be shading. Wait a minute. On the homework on question 14, that's what I'm going off of. It's saying for greater than, we shaded the left side and the middle. So you're right, it would have been opposite. Because you want to know what's above it. So in that way, that makes sense because you're highlighting the negative because you want to know what's above it. Okay. then less than would be the right side. So let me make sure that's okay. Here, shade that in. Okay, so I think, oh, it's the same thing. Okay. Maybe this is the same thing too. The greater one would be left and middle. Okay, so then 14 could be 0.99 4, which he said, oh, that makes sense because if you look at the okay, 0.99.
Oh my goodness.
5. Okay. So it's 0.995 for number 14. Because remember the probability. Anyway, okay, whatever.
No, you're good. So then we just have 12, 15, and 9 and 8 to do, right?
Yeah, which, yeah. But 8 and 9, yeah, you have to get 8 right to do 9.
Mm-hmm.
I don't know, in 12, I'm sure if I sat here long enough with all my notes and everything, figure it out. I don't know. What does 15 say? Oh, it's nice and lengthy.
So this is still finding probability.
Mm-hmm.
So we have to find the z-scored, plug it into the applet to find the probability, right?
Mm-hmm.
Okay. So first we do the z-score.
With okay.
So the value is 177.6 minus the mean. No, that's the 185 minus 177.6. So when we find the z-score, would we just divide it by the standard deviation, or would we divide it by the standard deviation and then divide that by the square root?
Well. Okay, so the variable minus the population.
What?
Standard deviation divided by the square root of sample size?
Yeah.
Formula you're doing?
Mm-hmm.
Okay, so then what?
So we're trying to find the z-score, right? So we would use the formula that is, oh, I just had it, where is it? The value minus the mean divided by standard deviation divided by the square root of the sample.
That'll give us the sample size, or the z-score.
So then for the equation, we would do 185 minus 177.6 divided by 26.7 divided by the square root of, is it 48? Because that's the random sample.
Yeah, 48. You're right.
Okay, so 185.
It says here, no, as extreme or more extreme mean. We are only interested in values that are lower than the ones but also values that are far away from the mean. Like R is in a positive direction. That makes I don't have no idea. I'm almost done here.
I need a calculator.
Is it done to take
Did you plug that in, Megan?
What's that?
So did you plug that in?
No, I did not. So. Will you read it to me?
Oh, the equation?
The numbers.
Yeah. So I did 185 minus 177.6
Okay.
divided by 26.7 divided by square root of 48.
Okay.
Hold on for just a minute. Let me mute myself.
Yeah. So did you get 19.20?
Okay. When I did it,
Yeah.
let me do it one more time.
Bye.
That's extreme.
Sorry, give me a sec.
Come
I have a, oh, sorry. Can I kiss on the cheek? Can I kiss on the cheek? Okay, bye. Drive safe.
Yeah.
Okay, tell your mom.
Yeah, when you're done with that, you can come to
I can come to your
Jamie's
house. Okay. Okay, tell your mom bye, sweetie.
Bye.
Bye. Sorry, I'm up at my parents' and my niece is up here.
That's fun.
Okay, so the 185 divided by 267 divided by. I just don't think I'm putting it in right in the proper.
Yeah, it's order of operations. It's
Yeah.
the thing is the square root, but you like my calculator. I could do second and then answer, and then it remembers it. Like it'll go back to whatever the answer was previously. That's how I do it.
Oh.
That's a good idea.
But that seems really, really high for a standard deviation.
It really does.
I got 1.92.
Wait, what?
I got 1.92. Don't ask me how. Ah.
Okay, this is what I'm
Or
going
z-score, I mean.
to break
But
it.
I don't even understand what it's asking, because what are we supposed to do next? That's my question.
Let me plug it into the applet. Let's see, what is 48 square root of?
But I know, but what are we trying to find? So it's saying find the probability that a random sample passage will have a weight that is extreme or more extreme, either above or below the mean that was observed in this sample. And the mean was the sample mean of 177.6. Is that what it's talking about here?
Mm-hmm. So we're finding the probability, which is why we have to plug it into the applet. So can I break this like the z-score formula down, can I like divide the 26.7 by the square root of 48? And then, okay, so when I broke it down like that, I got
1.92 breaking it down that way.
I got 1.068. Oh my gosh.
Okay.
Okay, one more time.
185 minus 177.6 is 7.4.
7.4.
So the square root of 48 is a whole bunch of numbers. 6.928203323, right?
Mhm.
Okay, so, but it's asking divided by, so 2.67. Maybe I have that wrong. Is that the 2.67?
Oh, it's 26.7 is standard deviation.
That's
26.7.
26.7. Okay, that's why I'm getting not correct. So 26.7 divided by, I'm going to do my last answer. And then I got 3.854. That makes more sense.
Yeah, that's what I got. So then it's 7.4 divided by 3.854.
No, that's the answer. It's divided by a whole bunch of other numbers.
So that's the probability, is the 3.854.
Yeah.
Okay.
But I still don't understand the question, what it's asking.
Oh boy, I don't either.
To find the probability that the random sample will have a weight that is extreme or more extreme.
So greater or equal to. So when I go to the individual preparation, after we compute the z-score, we can use the applet to find the probability
Right.
that a randomly selected mean will be above or below a given value of x. So
What do we highlight, I guess is my question.
So we are trying to find above or below. So if we're doing above, wouldn't we highlight the right side? I could be totally off my rocker, but wouldn't we? And what did we, so is the z-score the 3.854?
Yes.
Okay, so we can plug that in.
Wait a minute. So why you're saying it's above? So we want to find extreme or more. Oh, you're right. Okay. So no, according to the example last night, when he was finding greater than a value, he shaded the left side and the middle.
Oh, so if you shade it, that's right. So when you shade it, is that what the, like it's calculating the shaded part or it's calculating the unshaded part? Does that make sense?
Yeah, I don't know exactly. 8.54. Let me see what we get there. So then I got is 99.9. Or
oh, wait,
0.999. So
wait,
1.
What did you get for the z-score? You got the
0.854.
3.854, and then you plug that into the applet for area or for the, oh no, for the z-scores.
For the z-score, but I shaded the left and the middle.
Oh, left and middle.
First.
Okay, 3.854.
I don't know if that's right, but I'm going to just do it.
21.
Which would be like 1. I don't know.
Yeah, I'm just going to put that as well.
What are you putting?
So for 15, just 1.
For 15, just 1, you said?
Yeah.
Mm-hmm.
All right.
And you guys are both getting that?
Yeah.
Yeah, if you put it into the applet and you shade the middle and left side.
Yeah, if we did it correctly. But I don't know. If shading it would if it's not shaded correctly, you can get a different answer.
So do we want to go back and do number 8, 9, and 12?
Well, do we know more now? I don't feel like I know.
Probably not. I just want to write something down, you guys. I'm like so terrible and over this.
He's just tired. He's full. Did he drink his baba? Hi. Yeah. Just give him a spanking and hold him. He's tired.
No,
I know. Here. I'm almost done. Go.
can you put him in here with you?
No, I cannot. Pinky. You see, yeah, when we go back to 8, I just don't know what formula we're doing. Unless it's just the, well, no, remember we didn't know what the variable was,
Right.
right?
Mm-hmm. Wouldn't it be their scores though? But it wouldn't probably be the right number if we did 800 because it adds up to 800.
I did that. I did the 800.
So you would do the 800 minus 160 divided by, you divide it by the 8.8, and then would you do that with the square root or no square root?
I don't think with the square root.
Where are you getting 800? I'm sorry, I'm so
By adding all those numbers up.
Yeah, no, you're
dividing by 5 though, right?
Well,
To
that
get
would
them.
be sample mean.
well. That's the mean, right?
But the thing is, they gave us the mean.
Oh, they did. Where is it?
Well, a mean.
Oh, 150.8.
158.
What do we do? 800 divided by that or minus that instead? 800 minus 50 divided by.
Come here.
I feel like I needed to understand lesson 5 to be able to like really grasp this, right?
Mhm.
Or lesson 6. I think like, oh.
Wow, that is just not right. Okay. That's too big. 800, isn't that too big? Like it makes the z-score be like a ridiculously big number. But I mean, if that's the value, then it would make sense, but I don't know if that's the value. Because the value are, so like the value in the earlier question, in question 6 was 160 because it was her score. And so then in question 8, like they tell us the scores. So for the value of the scores, wouldn't you add them up? I'm so lost.
Yeah, I keep scrolling on my quiz and then I lose track of what number we're on again.
Me too.
You guys are on 7. 8.
8. Yeah. You guys, my computer is about to die, so I might just, I think that I'm just going to do the 800. And then I don't know what mean to use. Probably the sample mean, wouldn't it be? Because it says sample mean, which is just the mean out of the 5. So then I'm going to do 800 minus 160 because that was the mean.
Yeah. I did it where I wrote it down now. What do you get when you do that?
Let's see. Do you do, when you do you do standard deviation divided by the square root or no? Or do you just do it divided by standard deviation?
Let's do it by the standard deviation. What do you get?
Okay, so that would be 40 divided by 8.8. 72.727272.
Does that make sense? I mean, that's a huge z-score.
Yeah, but let's see. It's talking, yeah, but all of the scores are pretty large numbers.
Yeah. Okay. What is it? I'm going to do it.
72.72. That's what I'm doing. Sorry, you guys.
8.
Yeah, for 8.
Well,
7.7.
it's 3 decimals, though.
Oh, then 727 for 3 decimals.
So if we did that, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
So 8, you guys got 7 to what?
0.727.
72.727.
Yeah.
Yeah. You guys, it's gonna die. Oh no. Okay, I'm like freaking out. Hey,
You better, hey Annie, you better submit your quiz with whatever you have so you don't lose it. No, it saves it. Then go to the bathroom. Then come here.
so should I submit or save it?
Well, if you saved them all, it should be there even if your computer dies, right? When you come back.
If it doesn't, oh, you're brilliant. Save right now.
Just save all.
Is it working? This better work. Save.
And then you look on your left, and it should say how many questions out of 15 you've saved.
Oh no, it doesn't say it. Oh. Why is this not working? This is like terrifying. I swear if it's in all this work and it doesn't save.
Go each one and press save then.
I'll scroll to the top. Save. Shoot, I don't know why it's not saving. What is going on here? I might just submit it. I don't know. If my computer dies and then when I get home and I plug it back in, it should just pop up with the same stuff on it though.
Hopefully, yeah.
Don't you think?
You need to save the link too for this.
Oh my gosh, yes.
Just copy and paste it on a Word or something, Word document or something.
Copy.
So we are saving our quiz and then we're coming back to it later.
Oh, you guys can probably still work on it. I'm sorry. I am like the lamest. Okay.
No, fine. I don't know where to go from here. I might just take the grade whatever I get and just.
Me too. Take one.
We're only like 3-4 weeks in. I'm not going to base everything off of
right
one quiz, you know, like.
Is everything in the following weeks, is that all based off of everything we're learning now?
No, I think that once we take that exam, then it's like now we'll do the next so many lessons and then do another exam.
Okay.
But the final, yeah, we'll probably need all of this. Hi.
Hey, I ended up running over to Luke's.
Well,
It says he has an appointment at 3, or he has an
you guys, I don't know whether I think I'm gonna come back to it later. I don't know if you guys want to meet later or if you just want to submit it.
Yeah, I don't know. I'm gonna save it for now. I've got to get going.
Okay.
I gotta.
Yeah, me too. Okay.
So
Can I leave it open and work on it and then save it?
you?
Yeah. Or do we need to all be working on it at the exact same time? So like we need to save it.
I think it's okay because if anything, I would be fine just turning it in what I have and I'd be done.
Mhm.
But I don't know.
Okay.
I'm just all discombobulated right now that I can't even look over my notes. So to like see if I can figure out the last two. But
Right.
maybe we could just text each other.
Yep. Let's just keep in touch and we can decide if we want to meet or.
We did the bulk of it together, so.
Okay.
Mhm. Okay. And as soon as I get home tonight, I will post this link that I have saved.
Okay, cool.
Okay.
All right.
All right,
Thank
thanks,
you,
Joe.
guys.
We're gonna conquer.
See you guys later. I'm gonna go cry a little and then I'll be back.
Okay.
Okay. Thank you guys. Talk to you later. Bye.
Bye.